Okay, today in this video we're going to learn how to integrate trig functions, or the basic trig functions. Now, if you recall differentiation, when we, or if you're ever in any of my classes, I try and teach a little shortcut where I don't know where it came from really. I think it just reminds me of like a little coordinate quadrant. I don't know if that's right, but when you differentiate this kind of function, it goes to cos x. When you differentiate cos x, it goes to minus sine x. And then when you differentiate minus sine x, it goes to minus cos x. And then it repeats because minus cos x differentiated goes to sine x. And it just goes round and round and round. Now, we know that the opposite of differentiation is anti-differentiation. So I guess now if we follow, I'll try and use a different colour, we go back round this way, we can see that the integral of cos x becomes sine x. The integral of sine x becomes minus cos x. The integral of minus cos x becomes minus sine x, and the integral of minus sine x becomes cos x. So we're now looking at the green arrow. I hope you can tell the difference between the colours. All right, so let's also recall what happened when we differentiated functions of the form where there was perhaps a value of a in front of it. So I'm just going to use an example, y equals cos 2x. Now, when we differentiated this, we used the chain rule. And what we discovered is the derivative of this became, so cos we know goes to minus sine. So we get, cos when we differentiate it, apologies, goes to minus, I just had to double check that, minus 2 sine 2x. All right, now, if I was to set up an equation here, what I get is the integral of this becomes this. So the integral of minus 2 sine 2x with respect to x becomes cos 2x plus c. Now, let's suppose I wanted to generalize this and just say a function, I want to integrate sine ax, so sine 2x in this case. I'm going to pull the constant out front. So we get minus 2 times the integral of sine 2x with respect to x. Now I've changed the question now because now I'm saying I want to integrate positive sine 2x. With respect to x, and that still becomes this because this is my equation, so we get cos 2x plus c. Now, if I just want this, it's an equation, divide both sides by negative 2, leaving me with the integral, I think it's just going off the end there, try and write smaller, of sine 2x with respect to x equals 1 over, or negative 1 over 2 cos 2x plus c. And now I can generalize this and say, well, okay, the integral of sine ax, let's write it up here, the integral of sine ax becomes, with respect to x, let's just get the notation right, becomes negative 1 over a cos 2x, squeezing this on, plus c. Okay? And what we can do is we can apply this to all of these particular functions. So let's look at what happens when we integrate cos ax with respect to x. Well, cos of x, when we integrate that, naturally goes to sine x. And so we go equals 1 over a sine ax. Oh, that should be an a there. Ax plus c. Okay, and we can pretty much apply that to any of these. I can apply it to negative cos and negative sine x. I'm going to just run through some examples. Let me clear the space. Alright, just going to run through a couple of examples then. So with this one, we've got sine ax, where a is a half. So the integral of this becomes, well, sine, when it's integrated, goes to negative cos. So I've already got the negative cos, but I need to do 1 over a half. Now, obviously, you wouldn't write it like that. You'd simplify it to get negative 2. So this simplifies to be negative 2. Cos 1 half x plus c. So we get negative 2 cos 1 half x plus c. Now looking at this one, again, very similar situation. What we've got, I guess it confuses people when they see pi upon 4, but remember pi upon 4 is just a constant value. Our value of a is 3, and that's the key thing we need to know when we're integrating this. So our sine function, when integrated, as we've just said, goes to negative cos. And I'm going to divide by our value of a, which is 3, so we get negative 1/3 cos of 3x plus pi upon 4, and then plus c. And that's pretty much everything you need to know about integrating trig functions.